In this video, we're going to be solving some exponential equations. We're going to be looking at different ways of approaching these. We have 3 different equations here we're going to solve, and I've typed them up in increasing difficulty. So the first one, we have 5 to the power of negative x squared equals 5 to the power of negative 3x minus 4. You could see that they have the same base. Okay, they both have a base of 5. The base really doesn't matter as long as it's the same. So if they have the same base, we have what's called the one-to-one property, meaning that this exponent must be equivalent to that exponent, as long as they have the same base. So this we could rewrite as negative x squared is equal to negative 3x minus 4. And now we can try to solve this quadratic equation. So I'm just going to add x squared to both sides. And at this point, I am going to factor this. I could clearly see that this could be factored. And I'm going to use the zero product property. So x minus 4 is equal to 0, or x plus 1 is equal to 0. Therefore, x is equal to 4, or x is equal to negative 1. And I really should, at this point, check both of these to make sure that they work. I'll let you do that on your own. They both do end up working. So part B, we have another statement. We can see that our variable is in the exponent. So I want to use the one-to-one property, meaning I want to manipulate the equation so that it looks something like part A, where I have one term on each side of the equation with the same base, and then I could set the two exponents equal to each other. So what I'm going to do here is I'm going to divide both sides by 3. I have 3 times 2 to the power of x. So if I divide both sides by 3, then I get 2 to the power of x alone on the left side. Now I have, on the right side, I have 14. So how am I going to approach this at this point? Well, it's not super clear how I can go about this. I have 2 to the power of x. I want to get this 14 to look like 2 to the power of something, right? But 2 to the power of 3 is 8. That doesn't work. 2 to the power of 4 is 16. That doesn't work. So I know x is going to be between 3 and 4, but it doesn't exactly give me an answer. So I'm kind of stuck here. So I'm going to take a different route. I'm going to rewrite this using logarithms. And on both sides, I'm going to take the log base 2 of both sides. The log base 2 of 14. Okay, remember, this is kind of like a thought. That's not actually part of the problem. Okay, it's a step before that I'm looking at. So the reason I decided to take log base 2, well, you're going to see in a second. So now my x is a power. I can use my properties of logarithms, my power property, to take this x down front. So I have x log base 2 of 2 equals log base 2 of 14. Now, log base 2 of 2, well, let's see if I'll write this up here, okay? Log base 2 of 2 is equal to what number? Well, if I write that in exponential form, we have 2 to what power is equal to 2? Well, that question mark has got to be equal to 1. So I can rewrite this, the left side is simply x times 1, or x. That is the reason why I took the log base 2 of both sides of the equation, because I knew on the left side that was going to happen. And I would just be left with my exponent of x on the left side. So now I have log base 2 of 14 as being equal to x. Now, I could just say, you know what, that's my answer, right? If I don't have a calculator, there's not much more I could do with that. If I did have a calculator, then I could use my change of base formula there. And I could say x is equal to log of 14 divided by log of 2. Punch that into a calculator, and I would get, should do approximate, I would get about 3.807. Okay, one more of these. So, increasing difficulty here. You can see my variable is in the exponent of 2x minus 5. What I want to do is I want to get my 3 to the power of 2x minus 5 alone. So first I'm going to add 4 to both sides of the equation. So we have 2 to the power of 3 to 2x minus 5. Now I'm just going to divide both sides by 2, and I'll get that term with the exponent alone. And again, I'm sort of in this situation where I would love to rewrite that 6 as 3 to the power of something, right? But 3 to the power of 1 is 3, and 3 to the power of 2 is 9. None of them equals 6, so I'm stuck, right? That's a bummer again. So what I'm going to do now instead is I'm going to take the log base 3 of both sides. Okay, I'm going to log base 3 both sides. So now on the left side, I have log base 3 of 3 to the 2x minus 5 equals log base 3 of 6. Now the whole reason I did this, again, we saw this in the previous problem, I'm going to bring the 2x minus 5, the power, out front using my power property. And I'm left with log base 3 of 3, which I know that log base 3 of 3 is going to equal 1, and I'm just going to be left with 2x minus 5 times 1 on the left side. And the right side, I'm just kind of stuck for right now. Got log base 3 of 6 that's just sort of coming along for the ride here. Now, I just need to get my variable alone at this point. So let's just take this, and we're going to add 5 to both sides. We got 2x equals 5 plus log base 3 of 6. And now I'm going to divide both sides by 2. I'm going to have to take this up in this direction. So I'm going to get x is equal to, let's write this as 5/2 plus 1/2 log base 3 of 6. Now, I could just give this as a final answer, okay? But if I had a calculator, let's try to use a calculator here. So I'm going to use my change of base formula on log base 3 of 6. So I could rewrite this as 5 divided by 2 plus 1/2 times log of 6 divided by log of 3. Now, I'm going to try to enter this into a calculator. Let's see how this goes. So we have 5/2. I'm going to have to go back and forth here. I have 5 divided by 2 plus 1/2. Could have just entered that as 0.5. Log 6 divided by log 3. Log 6 divided by log 3. Double up those parentheses, and I get 3.315. We'll say x is about 3.315, and that would be my answer using a calculator. Okay, so that is how you use the one-to-one property and the properties of logarithms to solve exponential equations.